We're at the Construction Engineering Research Lab in Champaign, Illinois. It's owned by the Army Corps of Engineers. We have a combined team behind me of Marines from 7th ESB and a team of rockstar engineers from the Army Corps of Engineers, who are the minds behind our concrete 3D printer. In the past, we have successfully printed buildings. We have successfully printed and demonstrated a bridge. And right now we're working on improving the processes around the machine. So we know this machine can print, but we got to worry about the peripherals. The Marines from 7th ESB are the ones that designed what we're printing today. So they came up with the plans themselves, they catted up the model, and then they went through and sliced it, and we're feeding it to the printer, and the printer's going through and implementing it.
This week we're actually testing some new 3D printing systems that have larger bead sizes, larger hoses, as well as we're testing a continuous mixer. So what we want to be able to do is print with a larger bead so that we can print objects faster and print them stronger. This is really the first time we've ever printed something large with this system. So we're using this system in order to kind of figure out what the problems are we need to solve, tweak the mixtures, and get it to the point where we can use this in the field. So with this system, it's very experimental right now, and we're trying to push the technology forward. And this is the first time in the world anyone has really tried using these larger bead systems with these larger pumps.
I have a team of combat engineers from the construction shop and one of my other surveyors from 7th ESB. And we're basically just here assisting the U.S. Army Corps of Engineers in setting up the gantry, the mixer, and hopefully have a successful print. Keeping in mind mobility, counter-mobility, survivability, different ideas of what we can do. We went with the bridge with the last print, and for this one we wanted to see what we can do that's unique with the 3D printing in terms of construction, being able to print circular shapes, which normally you can't do by traditional means of construction. If we're forward deployed and we have this at a fob, we get it set up, we save on the wood it would take to build forms, a lot of materials that we'd end up having to ship overseas. If we take this thing, it packs up into an ISO container. Concrete's available in every country around the world, so we can get on station and start printing right away. We can, anything from jersey barriers to counter mobility for ECPs, whatever you can think of that's going to benefit the mission of where you're forward deployed.
My purpose here is I was actually the person that drew the blueprints for what we're doing today. Taking in consideration a lot of the different aspects and intricacies that go with 3D printing, I had to take all of those, collaborate it with the other DNS Marines, and we come out with the final product which allows them to print. 3D printing, as opposed to like regular construction that we do, it's a lot easier and we don't waste as much because we don't have to build forums for anything that we pour, or for any sort of SWA or CS or anything that we build. We don't end up wasting any material at the end. 3D printing is more beneficial for that and the amount of bodies that it takes to actually complete a project. So I know a lot of the times when we're in the field and we're building all those types of forums, it's a lot of man hours, and with this it only takes like 4 to 5 people to man, so it's fewer people and then shorter hours. Honestly, it's really cool. My background is in engineering, and so being that I joined the Marine Corps and continued in engineering and being like kind of like the first front with like experimental type things like this, it's a really big deal for me.